Hi, welcome to Unacademy. Very good evening, one to all. Could you confirm me audio and video? Yeah, please confirm me video and audio. Okay, Anurag. Hi. Good evening. Yes, myself is Kanakaya Chimitikanti, MTech from JNT Hyderabad, having more than 9 plus years teaching experience in GATE and ESE domain. Subjects taking are communication system, signals, advanced communication. Topics those are radar, satellite, optical wave, antenna. Of course, control system for the both. Now, whereas communication system we are taking daily 5 p.m. onwards in the Kreatryx channel. This is a part of an academy. So the classes will be Monday to Saturday. Sunday you don't have the class. Sunday we will have a special classes. This Sunday also we are having special class from 8:30 to 10:30 a.m. We are having special class on MAP and ML decoding techniques, guys. Yes, good evening. Unacademy is providing two beautiful courses. One is Plus course, another one is Iconic. In Plus course, unlimited live classes, crash courses, weekly test, doubt solving. Lectures will be in Hindi and English. In Iconic, personal coach, study planner, dedicated doubt clearing instructor, preparatory study material, study booster session, personalized test analysis. So, guys, for the Plus subscription, you can reach out to me. Use the code KN10. It will be beneficial. You will get the 10% discount. Let's see the prices list. For 12 months, 27,225. 18 months, 34,650. 24 months, 39,600. Very nominal prices, I can say. Whereas coming to the Iconic, for 12 months, it's a 45,225. For 24 months, 66,600. And these are the discounted prices after using the code. Clear? Unacademy Compact is going on. This is of worth of 3.5 crores when April 4th, 11th, 18th, 25. For enrolling, use the code same KN10 to enroll the course. It will be on every Sunday. All branches mechanical, civil, triple E, EC, CS, and IT. And these are the benefits of writing that compact. And the top three winners of each branch, you have the advantage that 100% free on plus subscription. And the top 100 members will have some more additional discounts, actually 10% more than that you will get. And these are the ranks what we achieved from GATE 2021. Single digit ranks in electrical 4th rank, 8th rank, ECE 179, in instrumentation 4th. These are the single digit ranks and plenty of ranks below 1000. Let's coming to today's session. That session will be on frequency modulation, guys. Today session is on frequency modulation. Very important. Definitely 2 to 4 marks, 2 to 3 marks possibility is there, guys. Yeah, all of you type hi in the chat box. Good evening. Just make your presence and think what is the definition for the frequency modulation, and think what is the definition for frequency modulation. What is the definition for frequency modulation? We already know it is a process of changing the carrier frequency linearly in according to amplitude variations of message. This is the definition for the good evening. This is the definition for the frequency modulation. Frequency modulation means process of changing the frequency of carrier linearly in according to amplitude variations of a message is called frequency modulation. Means here we are sending our message signal. Here we are sending our message signal information in the frequency variations of a carrier. Frequency variations of a carrier. Now, coming to the here, frequency modulation means FM. What is the FM radio you are using now? About that only we are discussing. So, in the frequency modulation, frequency is going to be varied. Let's take, for example, the carrier frequency before frequency modulation. Before modulation means any change in the carrier frequency? Obviously no. So same FC. Now I am writing the carrier frequency after frequency modulation. So here what will happen after the frequency modulation? After the frequency modulation, carrier frequency definitely will vary. That varied value I am indicating as some Fi. What is the meaning of that I also? I will get back. Here C means carrier. So the frequency of a carrier before modulation Fc. After frequency modulation I indicated with Fi. What is Fi, guys? Fi is the frequency of a carrier after modulation. Frequency of a carrier after modulation. Any doubt? Fun. What is the frequency modulation? Just now we discussed it. It's a process of varying the frequency of a carrier. So Fc is going to be varies according to amplitude variations of message. Here I am saying about amplitude variations, but we are adding to frequency. Here I am saying about the amplitude variations, but I am saying about the frequency. Are you getting my point? So can I add directly amplitude to frequency? Amplitude units are volts, frequency units are hertz. Can I add amplitude to frequency? No, there should be a proper conversion that is done by the parameter called Kf. What is Kf, guys? Kf is called frequency sensitivity. Very, very, very important term. Frequency sensitivity. What is the units for the frequency sensitivity, guys? What is the units for the frequency sensitivity? These volts we have to convert into hertz. So hertz per volt. What is the frequency sensitivity, guys? Try to understand. For example, I am saying if frequency sensitivity is 10 kilohertz per volt for suppose. What is the meaning? Yes, hertz per volt. What is the meaning here? Whenever message signal amplitude is varied by 1 volt, change the carrier frequency by 10 kilo. Are you getting my point or not? Here, what is the frequency sensitivity is, frequency sensitivity parameter will indicate how much change in the carrier frequency, how much change in the carrier frequency per 1 volt change in the message signal amplitude. Means I can say that this is a conversion rate of from voltage to frequency. You can also see guys here, this is a very important. Remember, frequency modulation is nothing but conversion of voltage into frequency. So what is FM? FM is nothing but guys voltage to frequency conversion. Are you getting my point? Amplitude modulation is amplitude to amplitude conversion. Frequency modulation means voltage to frequency. In the similar manner, this chapter will also comes about PM, phase modulation. Phase modulation means it's a conversion from voltage to phase, guys. Voltage to phase is phase modulation. Voltage to frequency, frequency modulation. At what parameter voltage is converting into frequency? The parameter of Kf. At the rate of Kf, frequency is converting into, voltage is converting into frequency. Where what is the meaning of I? I is called instantaneous. Where the frequency of a FM signal instantaneously varying the according to instantaneous amplitude variations of message. Where I means instantaneous frequency. What is the meaning of instantaneous? The meaning is where it is going to be varied according to amplitude variation instantaneous. So that's why called Fi. I means instantaneous, guys. Got the point? Here Kf is frequency sensitivity parameter. Frequency modulation is voltage to frequency conversion. Okay, Anurag. Fine. Let's see. Remember this instantaneous frequency. Where instantaneous frequency or frequency of a FM signal. For example, if message signal M of t is sinusoidal. Sinusoidal means either AM cos 2 pi FMT or AM sin 2 pi FMT. Message signal is a sinusoidal. Let's see how the sine signal, for example, this sine wave, maximum amplitude is AM, minimum is minus AM. Now follow. Now what I am writing is, guys, the maximum frequency of FM signal. Maximum frequency of FM signal I am indicating with F max. What is the meaning here? what is the maximum value of Fi. That is the maximum frequency I am saying. Maximum frequency of FM signal means the maximum value of Fi. So what is a FC? FC is a constant plus Kf also constant for each modulator. When Fi will be maximum whenever M of t is maximum. What is the maximum amplitude of M of t if it is a sinusoidal? Is AM. Are you getting my point or not? So this is the maximum frequency F max. In the similar manner, guys, the minimum frequency, of FM signal. Coming to the minimum frequency of FM signal, I am indicating with F minimum, guys. What is the F minimum? Whenever M of t is minimum, what is the minimum value of M of t? Is minus AM you have to take. This is the maximum and minimum frequencies of FM. Here F max means the maximum frequency of Fi. F minimum means the minimum frequency of Fi. Where FC I kept as it is, Kf constant. Where I taken M of t is a sinusoidal signal. Anyone having any doubt in this page, guys? Okay, Anurag, no doubt. Yeah, let's move on. Next point is the maximum frequency, deviation. Maximum frequency deviation is denoted with delta F. What is the maximum frequency deviation? Can anyone say? What is the maximum frequency deviation? Can anyone say? Is a maximum frequency deviation? Can you say? I told you about the maximum amplitude deviation. Okay, Anurag. The meaning is here. Let's see. Maximum frequency deviation means if you are observing where the original carrier frequency is Fc, this is maybe becoming is F max, or maybe it is becoming as F minimum. What is F max means? Maybe Kf AM is adding or Kf AM is deleting. Are you getting my point or not? The maximum frequency deviation means, let's see, how much it is deviating. How much it is deviating from Fc. Maybe it is becoming as F max, or maybe from Fc it is becoming as F minimum. So how much it is deviating from the original value? Just like for example, guys, I have 500 rupees in my pocket. I kept these 500 rupees on cricket betting. If I kept on cricket betting, if I win the match, I will get 1000. If I lose the match, I will get 0. In that example, what is the maximum change to my amount? What is the maximum change to my amount? Yes, the maximum change to my amount is, guys, KFAM only. So that KFAM is called maximum deviation. So actually delta f is not 1000 Anurag, it's a 500 only. If I win or if I lose the match, if I win I will get 1000, originally I have 500, now it is 1000 means 500 only the change. If I lose I will get 0, previously 500, now 0. So whether if I win or lose the match, maximum difference coming to my amount is 5 max to F minimum. This is the total swing. That is 2 times KF AM. That is nothing but 2 delta F. Now, okay, fine. This point is clear to all. What is the delta F as well as what is the total frequency swing? That point is clear. Okay. So here, what is the formulas you need to remember is, guys, the first one is Fi, instantaneous frequency. What is the instantaneous frequency? Fc plus Kf into m of t. Next we are having the formula for Fmax. What is Fmax, guys? Fmax is nothing but Fc plus Kf am if m of t is sinusoidal. What is F minimum? F minimum is nothing but, guys, Fc minus Kf am. What is delta F, guys? Delta F is Kf am. What is the total frequency swing? Total frequency swing is, guys, 2 delta F, of course, 2 Kf am. A simple things only. I think now we are getting with more clarity. Yes, Anurag? Now we are getting with more clarity, na? Yes. Let me take a simple question just for to understanding the terms only. In FM wave, carrier frequency is, in FM wave, carrier frequency is, for example, 1 megahertz, and the total frequency swing is total frequency swing is 400 kilo. Then calculate delta F comma F max comma F minimum. Simple question only, just for understanding the terms only. Simple question, just to recalling the terms. What is total frequency swing? Total frequency swing means 2 delta f, which is given 400k. Then what is delta f? Delta f is 200 kilo. Now what is f max? F max is, we already know, fc plus, I can also write delta f, which is kfam. Fc value 1 mega means 1000, delta f value 200, 1000 plus 200, 1200 kilo. What is f minimum? F minimum is fc minus delta f, guys. What is the fc value? 1 mega means 1000 kilo minus 400. 1000 minus 400, 600 kilo H's. Yeah, Anurag, you can please check once. Okay, 600 I written, na? Sorry. One second. 1000 minus 200, it's 800 kilo. Just here my intention is, you need to understand delta f as well as f max as well as f minimum. That is my intention of taking this problem. Anyone having any doubts? Very simple question. Let's see the next one more simple question, guys. The message signal m of t equal to, the message signal m of t equal to 5 cos 4 pi into 10 power 4t is frequency modulated by a carrier signal of frequency modulated by a carrier signal of frequency 2 megahertz, and frequency sensitivity is 15 kilo hertz per volt. Then calculate, what we need to calculate? Delta f, comma, f max, comma, f minimum. These are the things we need to calculate. Another simple question, just for you understanding the terms only. Do the question. You can give your answers. Yeah, Anurag here. First of all, calculate the delta F. What is delta F? KF into AM. What is the KF? 15K. What is AM? Message signal amplitude is 5. Then it will be 15 5 sir, 75K. Now, what is F max, guys? F max is nothing but FC plus delta F. FC 2 mega, 2 mega means 2000K, so 2075K. What is F minimum, guys? Coming to F minimum is called FC minus delta F, where 2000 minus 75, 1925K. Yes, another simple question. Here just I am writing or given the formulas for instantaneous frequency as well as delta F as well as F max and F minimum, guys. Now we will see the very interesting one, that is the waveforms of FM. From the waveforms there are number of things we need to calculate or we will get also. Let me take for example for example, rather than taking the sinusoidal message, I am taking some square waveform message for our clarity of understanding the waveforms. Apart from that, nothing is there. For example, this is the message. Now see. Always the carrier frequency is more. Let's take for your understanding the better way. In the each duration of the message, I am taking some 2 to number of cycles, guys. I am taking some 2 to number of cycles. Let's follow. Now I am writing the carrier signal, guys. Let's take this is the carrier. I am taking the carrier. Let's take it is having some more number of cycles in each duration of message. For example, I am taking 2 cycles. Little bit I can decrease in the down. In each duration of the message, in that off duration, I am taking some 2 to number of full cycles to indicate that carrier frequencies are more. Now try to recall the definition of a frequency modulation. Now try to recall the definition of a frequency modulation. What is frequency modulation? Now I am writing the FM signal. The frequency modulation definition is, guys, it's a process of changing the frequency of a carrier linearly in according to amplitude variations of message. So there is no change in the amplitude of a carrier before and after modulation. There is no change in the amplitude of a carrier before and after frequency modulation. Means same AC will be here also. If there is no change in the amplitude of a carrier before and after frequency modulation, I can say that power of the carrier before modulation is also equal to after modulation. Total power is also equal to PC only. In frequency modulation, the amplitude of carrier before and after FM is same. Before and after frequency modulation is same. Before and after is same means the power of carrier before and after FM is same. Before and after is same. That is here PT, total power, is also equal to carrier power. Means before modulation, if carrier is taking some 50 watts of power, even after frequency modulation also, for transmitting that signal, 50 watts will be sufficient. Means what is happening in frequency modulation is the power of the carrier before modulation, for example 50, that 50 now is converting into carrying our sidebands. In that 50, most of the power will be converted for carrying into sidebands. In FM there is no additional carrier, only a carrier small component will be there, that is taking very less amount of power. So that's why FM is called power efficient technique. FM is power efficient. In the yesterday one problem also came, I explained. So why it is power efficient, guys? FM is power efficient because here the power of the carrier before modulation is now converting into carrying the side bands. But in AM same PC will be as it is, additional PSBSC is coming. But in FM signal, the carrier power itself is converting into side bands. So in FM, no additional carrier, only a fraction of carrier. This point is clear. Now let me write the waveforms. Yes. Now there is no change in the amplitude. Here amplitude of the message is positive and maximum. So what you will get here? You will get here F maximum. Here message signal amplitude minimum and negative. So what you will get? F minimum. Frequency more, F max. Frequency less, F minimum. F max means frequency more means write the more number of cycles, guys. Writing more number of cycles means in the above I written 2 cycles. So here you can write the more. For example, I am writing some 4 cycles. Here frequency is minimum. So let's write the less number of cycles. Previously 2 I written. Now I am writing 1. One more time, frequency is more. So you will have the more number of cycles. Frequency minimum means less number of cycles. You can observe. Whereas cycles more and less means frequency increasing, decreasing like that. Got the clarity about the waveforms? And in the waveforms also one point we analyzed. Whereas the amplitude of a carrier before and after frequency modulation is the same. So that's why power of the FM signal will be equal to PC, carrier power only. So the power of the carrier after modulation is converting into carrying our sidebands. So that's why it is called power efficient. Here the meaning of efficient is Anurag. The point you need to understand whether it is a less or more. I am not saying efficient in the sense. Actually, the power of the unmodulated carrier here converting, that unmodulated power is converting for carrying the sidebands. PC is converting into PSB. Actually, that's a carrier power is means wasted power. Na? That waste value is converting. So that's why it is called power efficient. There is no such type of mechanism in SSB. Anyone having any other doubts? Now follow. Whereas in FM, guys, in FM, yeah, in FM, the amplitude of the FM signal is constant. The amplitude is constant means I can say that in FM, PT, total power is constant. In FM, total power is constant. But not in AM. This point is clear or doubt? In FM, there is no change in the amplitude of the peak values. If there is no change means PT constant, but whereas in AM you can see the peak values are varying, that is according to the message signal. So their PT is not constant, but in FM PT is constant. Now, if the PT is constant, what is the advantage is, guys? If PT is constant, what is the advantage is we can use our system's maximum efficiency levels. If PT is constant, we can use our systems maximum efficiency. Meaning is, guys, for example, suppose PT is 100. Let's take in FM. Whereas in AM, if I take PT is continuously varying minimum to maximum. Suppose it's varying from 20 to 100. Whereas in PT constant only. So I need at 100 watts. So I will also design my amplifier or my system which can work out at 100. I am also using it 100. Whereas in AM, guys, I am designing I have to work from 20 to 100 means I have to design the amplifier at 100. It can also work for 20. But I am designing for 100. I am not using always at 100. It's always varying from 20 to 100 continuously. If I radiate the AM signal for 10 minutes, maybe 1 or 2 minutes maximum values. Maybe 1 or 2 minutes maximum values. Remaining will be less than that only. Means you are designing the system at 100, but you are not, this for example I take, but we are not using always at 100. Means you are not using your systems effectively. Are you getting my point or not? If you are not using your systems effectively means that is a drawback only. Whereas in FM, I am designing at 100, I am using it 100, no problem. Okay, see the recorded one. Today is one of the beautiful session. Yeah, you can see the recorded one. Like that, guys, you can also use your efficiency maximum level. Then your system will be more effective. Now you will get the more effective success in your life. So if you are preparing for GATE, apply your maximum efficiency. And when you are preparing, sometimes disappointment, sometimes whether if I get or not, like lot of disturbances will be there in your mind. Keep all those disturbances outside, try to focus on. If any problem is there, you can think about that problem for some time. You can keep some time slot for that. After that, leave that problem. Remaining time slot, you can concentrate on things what you are learning and what should be our goal and how many marks should be our target. According to the target, work out. Got the point? Okay. The next thing is, guys, generally noise will affect amplitude more when compared to frequency. This is a general point. Generally, noise will affect, that is channel noise. Noise will affect the amplitude more when compared to frequency. So, I can say that FM is less affected by channel noise when compared to AM. Why? Because in AM the information is in the amplitude, where generally noise affect also amplitude more when compared to frequency. This is general point. So that's why generally AM signals are more affected by noise when compared to frequency. Generally, AM signals are more affected by noise when compared to frequency modulated signals. Next, the noise adding to amplitude of a FM signal, is called, the name is AM noise, or also called impulse noise. Noise adding to amplitude of FM signal is called AM noise or impulse noise. How the things, if noise is adding to the FM signal, AC minus AC, this FM signal means we are having sometimes more frequency, less frequency, like more frequency. Noise is adding to amplitude of the FM signal means here the noise may be add like this. So after adding the noise, the amplitude variations you will observe in the FM signal. So that's why it is also called AM noise, as well as this existing only at a peak points it is adding. Only at a point means, so also called impulse noise. Now there is no effect of this channel noise, guys. Why? Because if any noise is adding to amplitude of FM signal, actually in FM amplitude is constant. If any noise variations you got, means if any amplitude variations you got in FM signal, if any amplitude variations you got in FM signal, you can clearly knows that this is only because of noise, because we already knows that in FM there is no amplitude variations. In FM no amplitude variations. If any amplitude variations in the FM, it is only because of noise. So you can clip off those things by using a double-ended clipper circuit. So how much is up to where it is adding, that we can clip off. Even if you clip off the amplitude variations in FM, there is nothing will happen because our information is stored in the frequency variations of a carrier. But in AM, our information is also in the amplitude. Noise is adding to amplitude. We cannot differentiate because that amplitude variation may be because of message information or maybe because of noise. We cannot differentiate. But in FM, we can clearly differentiate, guys. But in FM, clearly we can differentiate. Why? Because if any amplitude variations came, that is only because of noise in FM. So that's why the FM systems are having one of the reason FM have more figure of merit. What is the figure of merit? I will tell you. When compared to AM. What is FOM, guys? FOM is called figure of merit, where this is the parameter for analysis of receiver capability. Figure of merit is more means the receiver is excellent one. What is the figure of merit value for FM? If you take for the FM, the figure of merit value is 3 by 2 beta square is the formula. Beta is the modulation index in FM, whereas in FM that beta value practically is 5. Substitute here 5. So 3 by 2 into 5 square 25. So it is a 37.5. Whereas the figure of merit value for AM is simply efficiency formula only. You will get that is a mu square by 2 plus mu square. Whereas maximum value for mu I can take 1. Even if you take the maximum value, it is 1 by 3 only. Let's see how much difference is there from figure of merit of FM to AM. See how much difference is there, the figure of merit of FM to AM. Got the point? Beta here mu is called what? Modulation index of amplitude modulation now. Where beta is the modulation index of frequency modulation. It will comes weight. As a point I am saying here, it will comes. Where beta is the modulation index of FM. Like mu is the modulation index of amplitude modulation. Figure of merit, see lot of differences there, as well as see the next point. 7, 8, that is the 9th point. This is the 9th point. And see the 10th point, guys. Atmosphere noise. Atmosphere noise are also called, guys, static noise. Atmosphere noise or static noise effect will be more. Effect will be more up to 20 megahertz. its effect is more up to 20 megahertz. Whereas what is the AM radio, guys? The AM radio is 550 kilo to AM radio is 550 kilo to 1650 kilo. Whereas FM radio is from 88 megahertz to 108 megahertz. Whereas in the static noise range, AM radio is there. So second. So AM radios are more affected by noise, more affected by static noise when compared to FM. Static or atmospheric noise means noise because of the rain, thunderstorms, as well as lightning effect, as well as meteors. All these are called static noise. Its effect is more up to 20 mega. Means up to 20 mega its effect will be there. After 20 mega very less. Whereas AM is in that range, so it is affected more when compared to FM. You can observe the AM radio and FM radio when the rain is going on. You will see the clarity difference. Got the point? See the next one. Any doubts, Anurag? Yeah, Satya, Anil. Guys, are you having any doubts? The clarity of the clarity of audio signal will be good in FM when compared to AM, guys. Clarity of audio signal will be good in FM when compared to AM. Why? Because the main reason is not only noise, the main reason is, guys, in AM audio signal, the maximum frequency what we are considering is only 5K. But in FM, guys, the maximum frequency of audio signal considered is up to 15K. Whereas audio signal frequencies are from 20 to 20 kilohertz. Whereas in AM only we are taking up to 5K, FM 15. So in FM we are considering more frequency components. So that's why the clarity of audio signal will be good in FM when compared to AM. This is the discussion about the waveforms of the FM. You can see. This is the waveforms of the FM. I can also write by taking sinusoidal, but if I take that triangular, it's looking like very nice, so that's why I take it. Now I will discuss you one wonderful topic you may not be experienced in the previous. Just wait for a time. Just wait for a moment. This is the points on the waveforms of the FM. Amplitude same, PT is same. Because of that we are having the advantage. where FM is power efficient. We can utilize the systems at maximum efficiency level. Generally, noise affect amplitude more, so AM signals are more affected by noise when compared to FM. And noise adding to amplitude of FM signal is called AM noise or impulse noise. This can be completely removed by using double-ended clipper circuits. And the figure of merit of FM is very high when compared to AM. So it is having a better qualities. Atmosphere that is static noise or atmosphere noise effect will be more on AM radio when compared to FM. Clarity of audio signal will be good in FM when compared to AM because of taking the more frequency component. Now, see guys, for example, if I take AM signal, let's recall the waveform of the AM. The waveform of the AM will be something like, it will be like that. This is the AM signal. By seeing the AM signal, you can say that guys, where is the message signal? For example, this is our AM signal. Where is the message signal? You can clearly observe the message signal will be on the amplitude variations of message. Are you able to see the message shape here? In AM signal, are you able to see the message signal shape? Yes, in amplitude. Are you able to see the message signal shape? Suppose if I write the FM signal guys, yes. Suppose if I write the FM signal guys, how the FM signal? This is the FM signal. This is the FM signal. In FM signal, are you able to see the message? In FM signal, are you able to see the message? In FM signal, are you able to see the message? No. So here visualization difficulty will be there from AM to FM guys. Here visualization difficulty will be there from AM to FM. How from the FM, how to get the message? From the FM, how to get the message? I will show you. Getting of message from FM. If you want to write the message, what are the things you need guys? The things you need that we have to know the amplitude of the message, as well as we have to know its polarity, as well as you have to know its frequency. These are the parameters we have to know for writing the message. How to calculate amplitude, how to calculate polarity, how to calculate frequency. How to calculate amplitude is, guys, the amplitude of a message signal is directly proportional to delta F. The amplitude of a message signal is directly proportional to delta F. Means, for example, guys, we will take the values and how to calculate those values we will see. Suppose, guys, let's take kf value is 1k. Let me take message signal. Message signal is varying from 0 to 5 volts. Negative side, let's take minus 5 volts. Let me take the carrier frequency initially. Let me take 100k. Now tell me what will happen. It is starting at 100k. As message signal frequency is increasing, this is a message signal amplitude increasing, its frequency will increase, it will goes to maximum value. What is the Fmax formula? Fmax formula is, guys, Fc plus Kfam. What is the Fc? 100k plus Kf value 1k, Am is 5, so it goes to 105. Now as message amplitude is decreasing, it is also decreases, and when m of t is becoming 0, it is becoming 0. Are you getting? As m of t is negative coming down, it is also decreases and becoming as a 95. Next it comes to 100. That is the variation of the FM signal frequency, that is Fi variation. As m of t amplitude is varying, it is also going to be varying, guys. Now we know this Kf value is standard. This is 1 kilo. Suppose if you are observing Fi value is 103k, what is the delta F? Delta F is, we know, 3k. Kf is a standard value. Then amplitude of the message will be 3 volts. Like if Fi value is, for example, some 94. What is the difference? Here polarity will get it. Difference delta F is 6. So definitely amplitude is 6 volts. Like we will calculate from the delta F. From the delta F we are going to be calculating the amplitude of a message. Don't bother about the sign. About the sign I will tell you. This point is clear. How to calculate the amplitude of the message from the FM signal, whereas it's directly proportional to the delta F. Now, how to get the polarity? Polarity we can get by checking the Fi value greater than Fc or less than Fc or equal to Fc. For example, if Fi value greater than Fc, then amplitude is positive polarity or negative polarity. Like if Fi equal to Fc, like if Fi less than Fc. What about in this case? Equal means definitely Am is 0. Now in this case, positive or negative. You can see here, whenever Fi value more means more than Fc means whenever amplitude is positive, because what is the Fi expression? The Fi expression is nothing but Fc plus Kf into m of t. Fc plus Kf into m of t. Yeah, Anurag, tell me, if frequency of FM signal greater than carrier frequency, now amplitude is positive or negative? Yeah, anyone guys, you can respond. Definitely this is because of positive. So that's why we are getting more. If Fi value, if Fi value less than Fc, if Fi value less than Fc, when you will get minimums. When Fi value will be less than Fc, you will get whenever m of t going for a negative cycle, means here amplitude is negative. Yes, that is the way of calculating the polarity. Amplitude is directly proportional to delta F. Polarity we can calculate by checking the FM signal frequency. That is, Fi value may be greater than Fc or less than Fc. Now, very interesting, how to calculate the frequency. How to calculate the frequency of the message. The frequency of the message is directly proportional to rate of change. That is d delta f by, that is d delta f by dt, guys. Whereas Fm is directly proportional to rate of change of frequency deviation. Rate of change of frequency deviation, guys. That is the Fm. What is this rate of deviation means, guys? Let's see. For example, guys, whereas the time period of the signal is, for example, 1 second. For example, its time period is 1 second. The time period is 1 second means, whereas Fi value 100 to 105, coming to 100, going to 95, coming to 100 now, this total time it will take 1 second to complete. If you know the time value, then frequency is nothing but 1 by time, means rate of delta f means rate of change of delta f means, if the time period is 1 second, it will to make all this work 100 to 105, 105 to 100, 100 to 95, 95 to 100, that total time will be taken is equal to the time period of a message. If it is taking 10 seconds, this is also taking 10 seconds. If it is taking 1 millisecond, this is also 1 millisecond, then frequency is 1 kilohertz. That is the rate of change of the frequency deviation. Got the point, Anurag? So these are the way calculating the message from FM. Whereas amplitude is proportional to delta F, frequency is proportional to rate of change of delta F, polarity coming to checking the Fi, that is the instantaneous frequency, are also called frequency of the FM. Where it is a greater than Fc or less than Fc, like that. Yeah, any doubts in the today's class? Okay, Anurag, there is a new initiative is coming. I think you are preparing for the ISRO examination. Na? Anurag, I think you are preparing for the ISRO examination. Na? So, no new initiative is coming from the 9th April. From the 9th April onwards, this is app, my special classes. From the 9th April onwards, every day morning 8:15 to 9 a.m. 8:15 to 9 a.m. we are discussing the PYQs of ISRO examination. We are discussing the PYQs of ISRO examination. Okay, na? The timing. Daily 10 to 15 questions we are discussing. Not only questions, the concept behind the question also we will discuss. Chances are there coming of ISRO notification? Yes, special class in the app. Yes, all the subjects. All the subjects. Because in ISRO, na, majority of the portion, more than 50% is communication related. Communication, satellite communication, wave propagation, antennas, radar, these topics only. Optical, I have very full command on that. Along with, I have the command on signals as well as control system also. So I will take the all subjects. All subjects. Most of the things you can feel 80 to 85%. All the things we will discuss. EDC, I promised you only that preparation strategy. So if you want, guys, we will take that preparation strategy video. Maybe on 5th. Can we take on 5th? Or guys, if you want, maybe on 3rd. At present, I cannot start the EDC in the special class also because signals going on and controls PYQs also coming, as well as ISRO series is there. So I cannot start the EDC. I will tell you the preparation strategy. Yes, on 3rd, okay. 3rd, we will discuss about the EDC preparation strategy. This will be the special class. I will create and I will share the link. This special class I will create and I will share the link. Clear, Anurag? Yeah, you can follow me on Unacademy, unacademy.com @Kanakaya. Use the code KN10 to unlock your free course. And access of my classes. And this is the Telegram channel Kreatryx Gate EE. And these are the India's best channels for GATE and ESE preparation. No. You can continue. Swami sir is also good. Excellent. Is my friend also. Yes, Swami sir is excellent in signals. No need of switching. You can continue. I am taking the special classes anyhow. You can continue your preparation from the Swami sir. These are the India's best channels for GATE and ESE preparation. Kreatryx GATE, Unacademy for Mechanical Civil. This is for the Civil Computer Science GATE questions like that. So don't forget to like the session as well as share the session, subscribe and share to your juniors. Click on the bell icon. Yes, thank you to all. Yes, about the timing also, Swami sir class is 7:30 to 9. Na? Okay. About the timing also we'll discuss, Anurag. Then it is better to start our timing also. What is the link for GATE batch? Link in the sense I am not getting DS. Link in the sense. Now this is the impulse batch. Okay. Link in the sense DS I am not getting. Timetable. For what you are looking for, the plus course or the free course?